Welcome back to another math lesson hosted by Book&Table. I'm your math tutor, Maurice Wright, and this is practice set number 1 to the 2x2 systems chapter. You'll have a chance to complete 18 questions that will help you practice both the substitution and elimination methods for solving 2x2 systems of equations. We'll also review how to find the solutions to systems of inequalities by graphing the systems. Should you have any follow-up questions, feel free to leave them in the comments section. Or you can contact a tutor in your neighborhood by visiting bookandtable.com or by downloading our app on the App Store. Question number 1. Solve by substitution and check the answer. Equation A, x is equal to 5. Equation B, x minus 2y is equal to 3. Pause the video, answer this question, and then press play when you are ready to begin. Step 1, substitute x into equation B here. Since we have the expression for one of our variables, x is equal to 5 is given to us, we can substitute this value into equation B and then solve for y. So when we plug 5 in for x here, we get 5 minus 2y is equal to 3. And to solve for y, we first want to subtract 5 from both sides, leaving us with negative 2y is equal to 3 minus 5, which is equal to negative 2. And to remove this coefficient of negative 2, we'll divide both sides by negative 2, giving us y is equal to negative 2 divided by negative 2, which is equal to 1. So this is the y-coordinate where the two lines cross, and we know the x-coordinate is equal to 5. So the solution to this system is the point where x is 5 and y is 1. And to check the answer, we want to plug the xy, 5, 1, into the original equations to confirm that they are both true with these values. Equation A is x is equal to 5. So when we plug in 5 for x, we get a true statement. 5 is equal to 5. So equation A checks out. And when we plug in x is 5 and y is 1 into equation B, we get 5 minus 2 times 1. 2 times 1 is 2, giving us 5 minus 2, which is 3. 3 equals 3, confirms that x is equal to 5 and y is equal to 1 for equation B as well. So that is the answer to question number 1. Let's now have a look at question number 2. Solve by substitution and check the answer. Equation A, y is equal to negative 2. Equation B, negative 3x plus 5y is equal to negative 4. Pause the video, answer this question, and then press play when you are ready to begin. Step 1, substitute y into equation B. So since equation A tells us that y is equal to negative 2, the value to one of our variables, we could substitute this value, negative 2, in for the variable y here, and then step 2, solve for x, giving us negative 3x plus 5 times negative 2, which is negative 10, is equal to negative 4. And to solve for x, we'll first want to add 10 to both sides, giving us negative 3x is equal to negative 4 plus 10, which is 6. And to negate this coefficient, negative 3, we'll divide both sides by negative 3, giving us x is equal to 6 divided by negative 3, which is equal to negative 2. So we see x is equal to negative 2 and y is negative 2 is the solution to question number 2. And now step 3, check the answer by plugging the xy, negative 2, into the original equations. When we do so, our first equation is y is equal to negative 2. When we plug in negative 2 for y, we get a true statement, negative 2 is equal to negative 2. And for equation B, when we plug in negative 2 for x and y, we get negative 3 times negative 2, which is equal to positive 6, plus 5 times negative 2, which is negative 10. 6 minus 10 is equal to negative 4, and that's equal to negative 4, thus confirming that the solution to question number 2 is the point where x is negative 2 and y is negative 2. That is the answer to question number 2. Let's now have a look at question number 3. Solve by substitution and check the answer. Equation A, x minus y is equal to 4. Equation B, 2x plus 3y is equal to negative 2. Pause the video, answer this question, and then press play when you are ready to begin. Step 1, isolate x on the left side of equation A. To do so, we'll take equation A, x minus y is equal to 4. And to move y to the other side, we'll add y to both sides, giving us x is equal to y plus 4. So now that we know what x is equal to, we can substitute this expression into equation B here, and then solve for y, leaving us with 2 times y plus 4 plus 3y is equal to negative 2. We want to distribute this 2 to both terms inside the parentheses, so that would give us 2 times y, which is 2y, and 2 times 4 will give us positive 8. Now we can combine the like terms, positive 3y and positive 2y, to give us positive 5y. And now, to solve for y, we first want to subtract 8 from both sides. When we do so, we get 5y is equal to negative 2 minus 8, which is negative 10. And to remove the coefficient 5, we'll divide both sides by 5, giving us y is equal to negative 10 divided by 5, which is negative 2. And now that we've solved for y, we can substitute y into equation A here, and then solve for x. And that would give us x minus negative 2 is equal to 4. X minus negative 2 would become x plus 2. Then we want to subtract 2 from both sides, leaving us with x is equal to 4 minus 2, which is positive 2. So we wind up finding that the solution is x is 2 and y is negative 2. And then to check the answer, step 6, we want to plug the xy to negative 2 into the original equations here and here to confirm that they work for both equation A and B. So when we plug in x is 2 and y is negative 2 into A, we get 2 minus negative 2, which would be 2 plus 2, and that's equal to 4, thus confirming that 2 and negative 2 does work for equation A. And now for equation B, 2x plus 3y is equal to negative 2. When we plug in x is 2 and y is negative 2, we get 2 times 2, which is 4, plus 3 times negative 2, which is negative 6. 4 minus 6 is equal to negative 2, thus confirming that x is equal to 2 and y is equal to negative 2 works for both equations A and B. So that is the answer to question number 3. Let's now have a look at question number 4. Solve by substitution and check the answer. Equation A, x plus 2y is equal to 5. Equation B, 3x plus 8y is equal to 11. Pause the video, answer this question, and then press play when you are ready to begin. Step 1, isolate x on the left side of equation A. We have x plus 2y is equal to 5. So we'll start by subtracting 2y from both sides, showing us that x is equal to negative 2y plus 5. And now that we have an expression equal to x, step 2, substitute x into equation B here, and that will allow you to solve for y, leaving us with 3 times negative 2y plus 5 plus 8y is equal to 11, giving us 3 times negative 2, which would give us negative 6y. 3 times positive 5 is positive 15, plus 8y is equal to 11. We can combine the like terms, positive 8y and negative 6y, to give us positive 2y. And now to solve for y, we want to subtract 15 from both sides, giving us 2y is equal to 11 minus 15, which is negative 4. And to remove this coefficient 2, we want to divide both sides by 2, showing us that y is equal to negative 4 divided by 2, which is negative 2. So now that we know the value for y, step 4, substitute y into equation B here, and then solve for x, giving us 3x plus 8 times negative 2, which would give us negative 16. To find x, we'll add 16 to both sides, showing us 3x is equal to 11 plus 16, which is 27. And to remove this coefficient 3, we want to divide both sides by 3, giving us x is equal to 27 divided by 3, which is 9. So the solution is the point where x is 9 and y is negative 2. And we can check the answer by plugging the xy, 9, negative 2, into the original equations to confirm that these two values work for both equations. So when we test equation A, we get 9 plus 2 times negative 2, which is negative 4. 9 minus 4 is equal to 5. 5 is equal to 5 confirms that x is equal to 9 and y is equal to negative 2. And now we can check with equation B. We plug in 9 for x and negative 2 for y, giving us 3 times 9, which is 27, plus 8 times negative 2, which is negative 16. 27 minus 16 is equal to 11. 11 is equal to 11 confirms that x is equal to 9 and y is equal to negative 2 is the solution to this system. And that is the answer to question number 4. Let's now have a look at question number 5. Solve by substitution and check the answer. Equation A, negative 4x plus 6y is equal to 8. Equation B, negative 2y plus 3x is equal to negative 3. Pause the video, answer this question, and then press play when you are ready to begin. Step 1, isolate x on the left side of equation A. So we'll take negative 4x plus 6y is equal to 8. And we'll first subtract 6y from both sides, giving us negative 4x is equal to negative 6y plus 8. And to remove this coefficient, negative 4, we'll divide both sides by negative 4, giving us x is equal to negative 6y divided by negative 4 can be simplified to positive 3y over 2. Positive 8 divided by negative 4 is equal to negative 2. So we get x is equal to 3y over 2 minus 2. To make life a little bit easier moving forward, we'll replace 3 halves with 1.5 since they're the same. So we see x is equal to 1.5y minus 2. So step 2, substitute x into equation B here and then solve for y, leaving us with negative 2y plus 3 times 1.5y minus 2 is equal to negative 3. We want to distribute this positive 3 to both terms inside the parentheses here, giving us 3 times 1.5y, which is 4.5y, and 3 times negative 2 gives us negative 6. We can combine our like terms, positive 4.5y and negative 2y, to give us positive 2.5y. Minus 6 is equal to negative 3. And now that we have just one variable y, we can solve for y. So we can add 6 to both sides, giving us 2.5y is equal to negative 3 plus 6, which is positive 3. And now we want to divide both sides by 2.5, giving us y is equal to 3 divided by 2.5, which is equal to 1.2. And now that we've solved for y, step 4, substitute y into equation A here, and then step 5, solve for x. When we plug in 1.2 for y, we get negative 4x plus 6 times 1.2 is equal to 8. 6 times 1.2 is equal to 7.2. Now we can subtract 7.2 from both sides, leaving us with negative 4x is equal to 8 minus 7.2, which is 0.8. And now to remove this coefficient of negative 4, we want to divide both sides by negative 4, showing us that x is equal to 0.8 divided by negative 4, which would be negative 0.2. So now we know the solution is where x is equal to negative 0.2 and y is equal to 1.2. So step 6, check the answer by plugging the xy, negative 0.2 and 1.2, into the original equations. When we plug them into A, we get negative 4 times negative 0.2, which would be 0.8, plus 6 times 1.2, which is 7.2. 0.8 plus 7.2 is equal to 8. 8 is equal to 8 confirms that x is equal to negative 0.2 and y is equal to 1.2 for equation A. And now for equation B, negative 2 times 1.2 is negative 2.4, plus 3 times negative 0.2, which is negative 0.6, and negative 2.4 minus 0.6 is negative 3. Negative 3 is equal to negative 3, confirms that x is equal to negative 0.2 and y is equal to 1.2, works for both equations. So that is the answer to question number 5. Let's now have a look at question number 6. Solve by elimination and check the answer. Equation A, negative 7x minus 2y is equal to negative 10. Equation B, 4x plus y is equal to 6. Pause the video, answer this question, and then press play when you are ready to begin. So we'll focus on eliminating our x first. So what we'll do is we'll multiply equation A times 4 so that we get negative 28x. And we'll multiply equation B times 7 so that we get positive 28x. And when we do so, when we distribute the 4 to the entire expression, we get 4 times negative 7x, which would give us negative 28x. 4 times negative 2y would give us negative 8y, and 4 times negative 10 gives us negative 40. And for equation B, 7 times 4x gives us positive 28x. 7 times y gives us 7y. And 7 times 6 gives us positive 42. So now we will be able to eliminate our x's once we add the equations together, giving us negative 8y plus 7y, which is negative y, is equal to negative 40 plus 42, which is positive 2. And now we want to solve for y, so we can multiply or divide both sides by negative 1 to get rid of this coefficient. If we multiply both sides by negative 1, we'll get y is equal to 2 times negative 1, which is negative 2. And now that we've solved for y, step 5, substitute y is equal to negative 2, into either equation A here or equation B here to solve for x. So we'll first plug it into equation A and solve for x, giving us negative 7x minus 2 times negative 2, which would be positive 4, is equal to negative 10. And now we'll want to subtract 4 from both sides, giving us negative 7x is equal to negative 10 minus 4, which is negative 14. And to negate this coefficient, negative 7, we'll divide both sides by negative 7, giving us x is equal to negative 14 divided by negative 7, which is positive 2. If you chose to substitute y into equation B instead, you'll get the same value for x, positive 2. So we get 4x minus 2 is equal to 6. And now we'll add 2 to both sides, giving us 4x is equal to 6 plus 2, which is 8. And now to negate the coefficient 4, we divide both sides by 4, giving us x is equal to 8 divided by 4, which is equal to 2. So we see that the solution is the point where x is 2 and y is equal to negative 2. And now step 7, check the answer by plugging the xy to negative 2 into the original equations, A and B. When we plug x is 2 and y is equal to negative 2 into A, we get negative 7 times 2, which is negative 14, minus 2 times negative 2, which is positive 4. Negative 14 plus 4 is equal to negative 10. And negative 10 is equal to negative 10 confirms that x is 2 and y is negative 2 for equation A. And now for equation B, 4 times 2 is equal to 8. 8 minus 2 is equal to 6. 6 is equal to 6 confirms that x is 2 and y is negative 2 for both equations, and thus is the solution to this 2 by 2 system. So that is the answer to question number 6. Let's now have a look at question number 7. Solve by elimination and check the answer. Equation A, 2x minus 5y is equal to 4. Equation B, negative 3x plus 3y is equal to negative 6. Pause the video, answer this question, and then press play when you are ready to begin. So for this question, to eliminate our variable x first, we'll want to multiply equation A times 3 so that we get 6x. And we'll want to multiply equation B times 2 so that we get negative 6x, allowing us to cancel out our x. So when we do so, we multiply the first equation times 3, giving us 3 times 2x, which is 6x. 3 times negative 5y is negative 15y. And 3 times 4 is equal to 12. And for equation B, 2 times negative 3x gives us negative 6x. 2 times 3y gives us 6y. And 2 times negative 6 gives us negative 12. So now, step 3, we add the equations together so that we can eliminate our x, and we can solve for y, giving us negative 15y plus 6y, which is negative 9y, is equal to 12 plus negative 12, which is 0. And to remove the coefficient, negative 9, we'll divide both sides by negative 9, showing us that y is equal to 0 divided by negative 9, which is equal to 0. And now that we've solved for y, we can substitute y into either equation A or B to solve for x. So if we plug y is equal to 0 into equation A, we wind up with 2x minus 5 times 0 is equal to 4. Negative 5 times 0 is 0, so that gives us 2x is equal to 4. And now we divide both sides by 2, giving us x is equal to 4 divided by 2, which is equal to 2. You also would have gotten x is equal to 2 if you plugged y is equal to 0 into equation B instead, giving us negative 3x plus 3 times 0, which would be 0, is equal to negative 6. And now we divide both sides by negative 3, showing us that x is equal to negative 6 divided by negative 3, which is positive 2. So the solution is where x is 2 and y is 0. And now step 7, check the answer by plugging the xy to 0 into the original equations. When we plug them into equation A, we get 2 times 2, which is equal to 4, minus 5 times 0, which is 0. So we get 4 is equal to 4. So that confirms x is 2 and y is 0 for equation A. And for equation B, we get negative 3 times 2, which is negative 6, plus 3 times 0, which is 0. So we get negative 6 is equal to negative 6, thus confirming that x is 2 and y is 0 for both equations, and thus is the solution to this 2x2 system. So that is the answer to question number 7. Let's now have a look at question number 8. Solve by elimination and check the answer. Equation A, 5x plus 4y is equal to negative 30. Equation B, 3x minus 9y is equal to negative 18. Pause the video, answer this question, and then press play when you are ready to begin. For this question, to eliminate our x's, we'll want to multiply equation A times 3 so that we get 15x. it will want to multiply equation b times negative 5 so that we get negative 15x, and that would allow us to eliminate our x variables. So when we do so, we multiply equation a times 3, giving us 3 times 5x, which is 15x. 3 times 4y is 12y. And 3 times negative 30 is negative 90. And now step 2, multiply equation b times negative 5, giving us negative 5 times 3x, which is negative 15x. Negative 5 times negative 9y is positive 45y. And negative 5 times negative 18 is positive 90. And now step 3, add the equations together. This will allow us to eliminate our x variable, leaving us with 12y plus negative 45y, which is negative 33y. And negative 90 plus 90 is 0. And now we can solve for y by dividing both sides by negative 33, giving us y is equal to 0 divided by negative 33, which is 0. And now that we found y, we can substitute y into either equation a or b to solve for x. So if you plugged y is equal to 0 into equation a, you would get 5x plus 4 times 0 is equal to negative 30, giving us 5x is equal to negative 30, since this is equal to 0. And to remove this coefficient of 5, we divide both sides by 5, showing us that x is equal to negative 30 divided by 5, which is negative 6. Or if you substituted y into equation b instead, you would have gotten 3x minus 9 times 0 is equal to negative 18. Negative 9 times 0 is 0. So 3x is equal to negative 18. And now you divide both sides by 3, showing us that x is equal to negative 18 divided by 3, which is negative 6. So we wind up finding that the solution is where x is negative 6 and y is 0. And to check this answer, we want to plug the xy, negative 6, 0, into the original equations. When we plug them into equation A, we get 5 times negative 6, which is negative 30, plus 4 times 0, which is 0. So negative 30 is equal to negative 30, confirms that x is negative 6 and y is 0. And for equation B, we get 3 times negative 6, which is negative 18, minus 9 times 0, which is 0. Negative 18 is equal to negative 18, confirms that x is negative 6 and y is 0, is the solution to this system. So that is the answer to question number 8. Let's now have a look at question number 9. Solve by elimination and check the answer. Equation A, negative 4x minus 16y is equal to 7. Equation B, negative 2x plus 3y is equal to negative 2. Pause the video, answer this question, and then press play when you are ready to begin. So in order to eliminate the x variable, we'll want to multiply equation b times negative 2. Negative 2 times negative 2x will give us positive 4x, which will allow us to cancel out negative 4x and positive 4x. So when we multiply equation b times negative 2, we get negative 2 times negative 2x, which is 4x. Negative 2 times 3y would give us negative 6y. And negative 2 times negative 2 will give us positive 4. And now step 2, add the equations together. Negative 4x cancels out positive 4x. Negative 16y minus 6y gives us negative 22y. And 7 plus 4 gives us 11. And now that we've eliminated one of our variables, we can solve for y. So we'll divide both sides by negative 22 to get rid of this coefficient, giving us y is equal to 11 divided by negative 22, which is equal to negative 1/2, or negative 0.5. So that is the y-coordinate where the two lines cross. Now, step 4, substitute y, negative 1/2, into either equation A or equation B, and then solve for x. So if you chose to plug negative 1/2 into equation A for y, that would give you negative 4x minus 16 times negative 1/2 is equal to 7. Negative 16 times negative 1/2 is equal to positive 8. And now to solve for x, we subtract 8 from both sides, giving us negative 4x is equal to 7 minus 8, which is negative 1. And to get rid of this coefficient, negative 4, we divide both sides by negative 4, giving us x is equal to negative 1 divided by negative 4, which gives us positive 1/4, or 0.25 for x. If you chose to plug in negative 1/2 for y into equation B instead, you should have gotten x is equal to 1/4 as well. So equation B would have given us negative 2x plus 3 times negative 1/2 is equal to negative 2. 3 times negative 1/2 is equal to negative 1.5. And now to solve for x, we add 1.5 to both sides, giving us negative 2x is equal to negative 2 plus 1.5, which is negative 0.5. And to get rid of this coefficient, negative 2, we divide both sides by negative 2, showing us x is equal to negative 1/2 divided by negative 2, which is positive 0.25. So the solution is x is 0.25 and y is negative 1/2. And we can check the answer by plugging the xy, 1/4, and negative 1/2 into the original equations. So when we plug them into A, we get negative 4 times 0.25, which would give us negative 1, minus 16 times negative 1/2, which gives us positive 8. Negative 1 plus 8 is equal to 7. And 7 is equal to 7 confirms that x is equal to 0.25 and y is equal to negative 0.5. And if we plug these values into equation B, we get negative 2 times 0.25, which is equal to negative 0.5, plus 3 times negative 0.5, which is negative 1.5. Negative 0.5 minus 1.5 is equal to negative 2. And negative 2 is equal to negative 2 confirms that x is equal to 0.25 and y is equal to negative 0.5 for equation B as well. So that is the answer to question number 9. Let's now have a look at question number 10. Solve by elimination and check the answer. Equation A, 6x minus y is equal to 4. Equation B, negative 4x plus 3y is equal to negative 5. Pause the video, answer this question, and then press play when you are ready to begin. So for this one, we'll want to multiply equation A times 4 so that we turn this into 24x. And we'll want to multiply equation B times 6 to give us negative 24x. That way we can eliminate our x in each equation and then solve for y. So step 1, multiply equation A times 4. In step 2, multiply equation B times 6. When we do so, we turn equation A into 4 times 6x will give us 24x. 4 times negative y will give us negative 4y. And 4 times 4 will give us 16. And for equation B, we get 6 times negative 4x will give us negative 24x. 6 times 3y will give us 18y. And 6 times negative 5 will give us negative 30. And now step 3, add the equations together. That will allow us to eliminate our x, giving us negative 4y plus 18y, which is 14y. And 16 plus negative 30 gives us negative 14. And to solve for y, we divide both sides by 14, giving us y is equal to negative 14 divided by 14, which is equal to negative 1. So that is the y-coordinate for where the two lines cross. To find the x-coordinate, we substitute this y value into either equation A or equation B, and then solve for x. So if we plug negative 1 in for y into equation A, we get 6x minus negative 1, which would be 6x plus 1, is equal to 4. And now we subtract 1 from both sides, giving us 6x is equal to 4 minus 1, which is 3. To negate this coefficient 6, we divide both sides by 6, giving us x is equal to 3 divided by 6, which is 1/2, or 0.5. If you chose to plug y is equal to negative 1 into equation B instead, you would have gotten negative 4x plus 3 times negative 1 is equal to negative 5. 3 times negative 1 is negative 3. And now we add 3 to both sides, giving us negative 4x is equal to negative 5 plus 3, which is negative 2. Negative 4x is equal to negative 2. So we divide both sides by negative 4 to give us x is equal to negative 2 divided by negative 4, which is 1/2, or 0.5. So we see the solution to question number 10 is the point where x is 0.5, or 1/2, and y is equal to negative 1. In step 7, check the answer by plugging the xy, 1/2, and negative 1 into the original equations. When we plug them into equation A, we get 6 times 1/2, which is 3, minus negative 1, which is plus 1. 3 plus 1 is equal to 4. 4 is equal to 4 confirms that x is 1/2 and y is negative 1 for equation A. And for equation B, negative 4 times 1/2 is negative 2. 3 times negative 1 is negative 3. Negative 2 minus 3 is negative 5. Negative 5 is equal to negative 5, confirms that x is 1/2 and y is negative 1 for both equations, and thus is the solution to this system. So that is the answer to question number 10. Let's now have a look at question number 11. Find the solutions by graphing the system of inequalities. Inequality A, x is less than negative 2. Inequality B, negative 3x plus 2y is greater than or equal to 5. Pause the video, answer this question, and then press play when you are ready to begin. Step 1, isolate y on the left side of inequality B. So we'll add 3x to both sides, giving us 2y is greater than or equal to 3x plus 5. And to get rid of this coefficient 2, we divide both sides by 2, giving us y is greater than or equal to 3x over 2 plus 5 over 2. 3x over 2 is equivalent to 1.5x, and 5 over 2 is equivalent to 2.5. So inequality B is equivalent to y is greater than or equal to 1.5x plus 2.5. And now step 2, change inequality A to an equation. We do so by changing the less than sign to equal to. And now that we have an equation for this line, we can create a value table for this line. Since x is equal to -2, this is going to be a vertical line where x is -2 on the x-axis. So our value table, each x value will be -2, and we'll use -1, 0, and 1 for y. So our points in this value table are -2, -1, -2, 0, and -2, 1. And now we'll create a value table for b. So step 4, change inequality b to an equation. So we change greater than or equal to equal to. And now we have y is equal to 1.5x plus 2.5. And now step 5, record 3 xy values for equation b in a value table. So we'll plug in -1, 0, and 1 for x, and then record the corresponding y values. So when we plug in -1 for x, we get y is equal to 1.5 times -1, which is -1.5. -1.5 plus 2.5 is equal to +1. So when x is -1, y is equal to +1. So we write that value down in our value table. And now we plug in 0 for x. And we see y is equal to 1.5 times 0, which is equal to 0. Plus 2.5 would give us 2.5. So 0, 2.5 is the second point in this value table. And now we plug in +1 for x. And we see y would be equal to 1.5 times 1, which is equal to 1.5. 1.5 plus 2.5 is equal to 4. So the third point in this value table is where x is 1 and y is 4. And now that we have value tables for a and b, we can find the vertex for where the two lines cross. So since equation A lets us know that x is equal to -2, we can substitute x into equation B here and solve for y. So that would give us y is equal to 1.5 times -2, which is equal to -3, plus 2.5. -3 plus 2.5 is equal to -0.5. So we get x is -2 and y is equal to -0.5. So that is our vertex where a and b cross. And now we can plot the vertex and sketch a and b to find our solutions. So step 8, plot the vertex. So we'll want to sketch an xy coordinate plane and plot the vertex where x is -2 and y is -1/2. So once you sketch your xy axes, you go to -2 and down to -0.5 and plot the point. And now step 9, plot the points from the value table of equation A. So you go back to that value table in your notes and you plot the first point, -2, -1. Then you plot the second point, -2, 0. And the third point, -2, 1. And now we have 3 points that will allow us to sketch A. So step 10, draw a dotted line through the points. And now we can do the same for B. So step 11, plot the points from the value table of equation B. So the first point is -1, 1. The second point is 0, 2.5. And the third point is 1, 4. And once you plot those 3 points, we can sketch B by drawing a line through the points. A is a dotted line since it is less than but not equal to. And B is a solid line since it is equal to. And now that we have our lines for A and B, we now want to shade the regions where we can find our solutions. So since inequality A we have less than, we are going to go to inequality A and we're going to shade the area to the left of inequality A. Since our x values get smaller as we move to the left. And now step 14, we shade the area above inequality B since we have greater than. So we go to inequality B and we shade all the points above that line. And the area of solutions will be the points between this line and this line here, since this is where our areas overlap. So this would be the answer to question number 11. So that is the answer to question number 11. Let's now have a look at question number 12. Find the solutions by graphing the system of inequalities. Inequality A, 2x minus 6y is greater than or equal to 10. Inequality B, negative x minus 3y is less than or equal to 7. Pause the video, answer this question, and then press play when you are ready to begin. Step 1. Isolate y on the left side of each inequality. So we'll begin with A. 2x minus 6y is greater than or equal to 10. So we'll start by subtracting 2x from both sides, leaving us with negative 6y is greater than or equal to negative 2x plus 10. And now we'll divide both sides by negative 6 to get rid of this coefficient. When we divide both sides by a negative number, we need to reverse this inequality sign from greater than to less than. And we'll wind up with negative 2x over negative 6, which can be simplified to x over 3. And 10 divided by negative 6 can be simplified to negative 5 over 3. So we wind up with y is less than or equal to x over 3 minus 5 over 3. So this is equivalent to the expression for A. And now we'll do the same thing with B. Negative x minus 3y is less than or equal to 7. So we'll add x to both sides, giving us negative 3y is less than or equal to x plus 7. And now we'll divide both sides by negative 3. We need to reverse this inequality sign since we're dividing both sides by a negative number. So we get y is greater than or equal to negative x over 3 minus 7 over 3. So now that we have y on the left side for A and B, we can now create value tables for both. Step 2, change inequality A to an equation. So we want to change less than or equal to an equal sign. And now we want to plug in negative 1, 0, and positive 1 for x, and then record the corresponding y value. So step 3, record 3 xy values for equation A in a value table. When we plug in negative 1 for x, we get negative 1/3 minus 5/3, which will give us negative 6/3. Negative 6 over 3 is equal to negative 2. So when x is negative 1, y is negative 2. When we plug in x is equal to 0, we get 0 minus 5/3, which is equal to negative 5/3. So when x is 0, y is negative 5/3, or negative 1.66. And when we plug in positive 1 for x, we get 1/3 minus 5/3, which would be equal to negative 4/3. And that's equivalent to negative 1.33. So now that we have a value table for A, we want to create a value table for B. So step 4, change inequality B to an equation. So we change greater than or equal to equal to. And now we plug in negative 1, 0, and positive 1 for our x, and then record the corresponding y value. So step 5, record 3 x, y values for equation B in a value table. So when we plug in x is equal to negative 1, we get negative 1 times negative 1, which is positive 1. 1/3 minus 7/3 is equal to negative 6/3. Negative 6 over 3 is equal to negative 2. So when x is negative 1, y is negative 2. When we plug in x is equal to 0, we wind up with 0 minus 7/3, which is equal to negative 7/3, or negative 2.33. And when x is positive 1, we wind up with negative 1/3 minus 7/3, which is equal to negative 8/3. Negative 8 over 3 is equal to negative 2.66. So 1, negative 2.66 is the third point in this value table. And now that we have value tables for both A and B, we want to find the vertex where A and B cross. So we'll write out the equations for A and B. And we have positive x over 3 and negative x over 3. So if we add the equations together, we can eliminate our x, leaving us with y plus y, which is 2y. And negative 5/3 minus 7/3 is equal to negative 12 over 3, which is negative 4. And now, to solve for y, we want to divide both sides by 2, showing us y is equal to negative 4 over 2, which is equal to negative 2. So now that we know y is equal to negative 2, we can substitute y into equation A or B here, and then solve for x. So when we plug in negative 2 for y into equation A, we get negative 2 is equal to x over 3 minus 5 over 3. And since we are dealing with fractions that have a denominator of 3, we want to change negative 2 to negative 6 over 3. It'll make it easier now to add 5/3 to both sides, leaving us with x over 3 is equal to negative 6 plus 5 is equal to negative 1/3. And now we have negative 1/3 is equal to x over 3. So to remove this denominator of 3, we want to multiply both sides by 3. When we do so, the denominator cancels out, leaving us with x is equal to 3 times negative 1 will give us negative 3 over 3. Negative 3 divided by 3 is negative 1. So we get x is equal to negative 1 for equation A. We'll get the same value for x if we substitute y into B instead. So negative 2 or negative 6 over 3 is equal to negative x over 3 minus 7/3. We want to add 7/3 to both sides, giving us negative 6 plus 7, which is positive 1/3, is equal to negative x over 3. And now, to get rid of the negative and the denominator of 3, we'll want to multiply both sides by negative 3. That will leave us with positive x is equal to negative 3 times 1 is negative 3. Negative 3 divided by 3 will give us negative 1. So we find that the vertex for A and B is where x is -1 and y is -2. And we have value tables for both A and B. So now we can begin graphing this system. So step 10, plot the vertex where x is -1 and y is -2. And once you plot the vertex, go back to your notes to the value table for A. And step 11, plot the points from the value table. Our first point is -1, -2. Our second point is 0, -1.66. And our third point is 1, -1.33. So with these 3 points now, we have enough to sketch A. So step 12, draw a line through the points. And it's a solid line since we have less than or equal to. So the or equal to makes it a solid line instead of a dotted line. And now we can begin working on B. So step 13, plot the points from the value table of equation B. Our first point is -1, -2. Our second point is 0, -7/3. And our third point is 1, -8/3. And with these 3 points, we can now sketch B. Step 14, draw a line through the points. And a solid line since it's or equal to. And now step 15, shade the area below inequality A. We're shading the part below since it's less than. So you go to A and you shade all the points below that line. And step 16, shade the area above inequality B. We're shading the area above since it's greater than. So we go to B and we shade the points above B. And the area of solutions will be where the 2 sets of solutions overlap, which will take place between these 2 lines here. So this would be the solution to question number 12. So that is how you solve question number 12. Let's now have a look at question number 13. Find the solutions by graphing the system of inequalities. Inequality A, -5x plus y is greater than -10. Inequality B, -3x plus 3y is greater than or equal to 6. Pause the video, answer this question, and then press play when you are ready to begin. Step 1, isolate y on the left side of each inequality. So starting with A, -5x plus y is greater than -10. We'll add 5x to both sides, giving us y is greater than 5x minus 10. So we'll rewrite A with this expression. And now B, we have -3x plus 3y is greater than or equal to 6. So we'll start by adding 3x to both sides, leaving us with 3y is greater than or equal to 3x plus 6. And now to remove this coefficient of 3, we divide both sides by 3, giving us y is greater than or equal to 3x divided by 3 would just be x, and 6 divided by 3 would be +2. So B can be rewritten as y is greater than or equal to x plus 2. And now we want to create value tables for both A and B. So step 2, change inequality A to an equation. So we change greater than to equal to. And now step 3, record 3 xy values for equation A in a value table. So we'll plug in -1, 0, and +1 for x, and then record the corresponding y value. When we plug in -1 for x, we get 5 times -1, which is -5. -5 minus 10 is -15. So when x is -1, y is -15. When we plug in 0 for x, we get 5 times 0, which is 0. Minus 10 will give us y is equal to -10. So when x is 0, y is -10. And when x is +1, we get 5 times 1, which is 5. 5 minus 10 is equal to -5. So when x is 1, y is -5. So now we have a value table for equation A. So we'll put that to the side and create a value table for B. So step 4, change inequality B to an equation. So we change greater than or equal to an equal sign. And now we want to plug in -1, 0, and +1 in for x and record the 3 corresponding xy values. When we plug in -1 for x, we get y is equal to -1 plus 2, which is +1. So -1, +1 is 1 point in this value table. When x is 0, y is equal to 0 plus 2, which is 2. So 0, 2 is the second point in this value table. And when x is +1, we get 1 plus 2, which is equal to 3. So when x is 1, y is 3 is the third point in this value table. So now you can put these two value tables to the side so that we can find the vertex where A and B cross. So you write out the two equations for A and B. Y is equal to 5x minus 10, and y is equal to x plus 2. And since we can't eliminate our x's here, we'll eliminate our y's. So y minus y will give us 0. So we subtract equation B from equation A, giving us y minus y, which is 0, is equal to 5x minus x, which is 4x. And -10 minus 2 is -12. And now that we've eliminated our y variable, we can solve for x. So we have 0 is equal to 4x minus 12. So we'll add 12 to both sides, giving us 12 is equal to 4x. And now we divide both sides by 4, showing us x is equal to 12 divided by 4, which means x is equal to 3. So now that we've found our x-coordinate for the vertex, we can find the y-coordinate by substituting x into either equation A or B and then solving for y. So we'll plug x is equal to 3 here and then solve for y. So when we plug it in here for A, we get y is equal to 5 times 3, which is 15. 15 minus 10 is equal to 5. So we see the y-coordinate is 5. If you plugged in x is equal to 3 here instead to find your y, that would give you y is equal to 3 plus 2, which is also 5. So the vertex for A and B is where x is 3 and y is 5. And we have value tables for A and B, so we can begin graphing. So step 10, plot the vertex where x is 3 and y is 5. And now go back to the value table for equation A and plot the points. The first point is -1, -15. The second point is 0, -10. And the third point is 1, -5. And now with these 3 points, we'll be able to sketch the line for A. So step 12, draw a dotted line through the points. And it's dotted since it's greater than but not equal to. And now we can repeat this process for B. So go back to the value table for B in your notes. In step 13, plot the points. So the first point is -1, +1. The second point is 0, +2. And the third point is +1, +3. And with these 3 points, we can now sketch B. And it's a line since it's greater than or equal to. So with the lines for A and B sketched, we can now use our inequality signs to shade the appropriate areas. So step 15, shade the area above inequality A. We're shading above since it's greater than. So we go to A and we shade the points above that line. And now step 16, shade the area above inequality B. And it's above since again we have greater than. So we go to B and we shade the points above that line. And the area of solutions can be found between this line here and this line here, since these points are the solutions for both A and B. So this would be the solution to question number 13. So that is how you solve question number 13. Let's now have a look at question number 14. Find the solutions by graphing the system of inequalities. Inequality A, 4x plus 2y is greater than or equal to 6. Inequality B, negative 3x plus y is less than negative 7. Pause the video, answer this question, and then press play when you are ready to begin. Step 1, isolate y on the left side of each inequality. So starting with A, 4x plus 2y is greater than or equal to 6. We'll subtract 4x from both sides, giving us 2y is greater than or equal to negative 4x plus 6. And now we'll divide both sides by 2, giving us y is greater than or equal to negative 4x divided by 2 will give us negative 2x, and positive 6 divided by 2 will give us positive 3. So we can rewrite A with y is greater than or equal to negative 2x plus 3. And now for B, we have negative 3x plus y is less than negative 7. So we'll add 3x to both sides, giving us y is less than 3x minus 7. So we can rewrite B with this expression. And now step 2, change inequality A to an equation. So we change greater than or equal to equal. So now we want to plug in negative 1, 0, and positive 1 for x, and then record the corresponding y value. When we plug in negative 1 for x, we get negative 2 times negative 1, which is positive 2. 2 plus 3 is equal to 5. So when x is negative 1, y is 5. When we plug in 0 for x, we get y is equal to negative 2 times 0, which is 0. Plus 3 will give us 3. 0, 3 is the second point in this value table. And when x is equal to positive 1, y is equal to negative 2 times 1, which is negative 2. Negative 2 plus 3 is equal to positive 1. So the third point is 1, 1. So now we have a value table for A. So put that to the side and repeat the process for B. So step 4, change inequality B to an equation. So we change the less than sign to equal. And now we plug in negative 1, 0, and positive 1 for x and record the 3 corresponding xy values. So when x is negative 1, we get y is equal to 3 times negative 1, which is negative 3. Negative 3 minus 7 is equal to negative 10. So the first point is negative 1, negative 10. When x is 0, we get 3 times 0, which is 0. 0 minus 7 is equal to negative 7. So 0, negative 7 is the second point in this value table. And when x is positive 1, we get 3 times 1, which is 3. 3 minus 7 is equal to negative 4. So 1, negative 4 is the third point in this value table. And now that we have value tables for A and B, we want to find the vertex where A and B cross each other. So we write out both equations. And since we won't be able to eliminate our x's, we'll focus on our y's. So we'll subtract equation B from equation A. That gives us y minus y, which is 0. And now that we've eliminated our y, we can solve for x. We get negative 2x minus 3x, which is negative 5x. And 3 minus negative 7 becomes positive 10. And now we want to subtract 10 from both sides, giving us negative 10 is equal to negative 5x. And now we divide both sides by negative 5, showing us x is equal to negative 10 divided by negative 5, which is positive 2. And now we can substitute x into A or B and then solve for y. So step 8, substitute x into either equation A or B, and then step 9, solve for y. When we plug it into A, we get y is equal to negative 2 times 2, which is negative 4, plus 3. Negative 4 plus 3 is equal to negative 1. So we get y is equal to negative 1. But if you plugged in x is 2 into equation B instead, that would have given you y is equal to 3 times 2, which is 6. 6 minus 7 is equal to negative 1. So the vertex is where x is 2 and y is negative 1. And we have value tables for A and B, so we can begin graphing. So step 10, plot the vertex where x is 2 and y is negative 1. And now go back to the value tables. In step 11, plot the points from the value table of equation A. So our first point is negative 1, positive 5. Our second point is 0, 3. And our third point is 1, 1. And with these 3 points, we'll be able to sketch A. So step 12, draw a line through the points. And it's a solid line since we have greater than or equal to. And now we focus on B. So step 13, plot the points from the value table of equation B. So our first point is negative 1, negative 10. Our second point is 0, negative 7. And our third point is 1, negative 4. And with these 3 points, we can now sketch B. So step 14, draw a dotted line through the points. And now step 15, shade the area above inequality A. We're going to shade above since A has greater than. So you go to A and you shade the points above that line. And now step 16, shade the area below inequality B. We're going to shade below since it's less than. So we go to B and shade the points below that line. In the area of solutions where they overlap occurs between this line here and this dotted line here. So this would be the answer to question number 14. So that is how you go about solving question number 14. Let's now have a look at question number 15. Find the solutions by graphing the system of inequalities. Inequality A, x is less than or equal to 3. Inequality B, y plus x is less than 2. Inequality C, y plus 2x is greater than 1. Pause the video, answer this question, and then press play when you are ready to begin. Step 1, isolate y on the left side of inequalities B and C. So with B, we'll subtract x from both sides, giving us y is less than negative x plus 2. So we'll rewrite b with this expression. And now for c, we want to subtract 2x from both sides, giving us y is greater than negative 2x plus 1. So we can rewrite c with this expression. And now we want to create value tables for a, b, and c. So step 2, change inequality a to an equation. So we change less than or equal to an equal sign. X is equal to 3 means that in our value table, all the x values will be 3. So we'll use negative 1, 0, and positive 1 for our y's, showing us this is a vertical line where x is 3. So now we create a value table for b. So step 4, change inequality b to an equation. So we change the less than sign to equal. And now we want to plug in negative 1, 0, and positive 1 for x and record the corresponding y values. So when x is negative 1, y is equal to negative 1 times negative 1, which is positive 1. 1 plus 2 is equal to 3. So the first point in this value table is negative 1, 3. When x is equal to 0, we get y is equal to negative 1 times 0, which is 0. 0 plus 2 is equal to 2. 0, 2 is thus the second point in this value table. And the third point is when x is equal to positive 1, y is equal to negative 1 times 1, which is negative 1. Negative 1 plus 2 is equal to positive 1. So 1, 1 is the third point in this value table. So we put this value table to the side, and now we want to create one for c. So step 6, change inequality c to an equation. And now step 7, record 3 xy values for equation c in a value table. So when x is negative 1, y is equal to negative 2 times negative 1, which is positive 2. 2 plus 1 is equal to 3. So negative 1, 3 is the first point in this value table. Our second point is when x is equal to 0. Y is equal to negative 2 times 0, which is 0. 0 plus 1 is equal to 1. So 0, 1 is the second point in this value table. Our third point is when x is positive 1. Y is equal to negative 2 times 1, which is negative 2. Negative 2 plus 1 is equal to negative 1. So 1, negative 1 is the third point in this value table. So now we put our value tables to the side, and now we want to find the vertices. So this is where A and B cross, A and C cross, and B and C cross each other. So we'll start by finding the vertex for A and B. So step 8, substitute x is equal to 3 into equation B here. Equation A, x is equal to 3. So we want to plug that value in here and then solve for y. So we get y is equal to negative 1 times 3, which is negative 3, plus 2 will be equal to negative 1. So the vertex for A and B is where x is 3 and y is negative 1. And now we find the vertex for AC. So we take equation A where x is equal to 3 and we substitute it into equation C here for x. And then step 11 we'll solve for y, giving us y is equal to negative 2 times 3, which is negative 6. Negative 6 plus 1 is equal to negative 5. So we see the vertex for AC is where x is 3 and y is negative 5. And now our last vertex is where B and C cross each other. So we want to write the equations for B and C. And since we cannot eliminate our x variable by adding or subtracting these equations, we'll focus on our y. Since we have positive y in both, we want to subtract equation C from equation B to eliminate the y, giving us y minus y, which is 0. negative x minus negative 2x is negative x plus positive 2x, which is positive x. And 2 minus 1 is 1. And now we can solve for x by subtracting 1 from both sides, showing us x is equal to negative 1. And now we can substitute x into either equation b or c to solve for y. So if we plug negative 1 in for x into equation b, we get y is equal to negative 1 times negative 1 is positive 1. 1 plus 2 is equal to 3. So the vertex for BC is where x is negative 1 and y is 3. But if you plugged in negative 1 into equation C instead to solve for y, you would have gotten y is equal to negative 2 times negative 1, which is positive 2. 2 plus 1 is equal to 3. So we see if you substituted x into b or c, you would get y is equal to 3. So the vertex for BC is negative 1, 3. So now we have all three vertices, and we have value tables for A, B, and C, so we can begin graphing. So step 16, plot the vertices. So sketch out your coordinate plane. And we plot vertex AB at 3, negative 1. We plot AC at 3, negative 5. And we plot BC at negative 1, positive 3. And now that we plot the vertices, go back to the value table for A. In step 17, plot the points from the value table of equation A. Our first point is 3, negative 1. Our second point is 3, 0. And our third point is 3, 1. So with these 3 points now, we'll be able to sketch A. So step 18, draw a line through the points. And it's a solid line since we have less than or equal to. So the or equal to makes it solid. And now let's work on B. So step 19, plot the points from the value table of equation B. So our first point is negative 1, 3. Our second point is 0, 2. And our third point is 1, 1. And now with these 3 points, we'll be able to sketch B. So step 20, draw a dotted line through the points. And it's dotted since it's less than but not equal to. And now step 21, plot the points from the value table of equation C. So our first point is negative 1, 3. Our second point is 0, 1. And our third point is 1, negative 1. So with these 3 points, we'll be able to sketch C. So step 22, draw a dotted line through the points. And now that we have the lines for A, B, and C, we can begin shading the appropriate areas. So step 23, shade the area to the left of inequality A. For A, we have x's less than or equal to 3. Our x's have smaller values to the left. So that's why we shade these points. And now for B, step 24, shade the area below inequality B. We're shading below since it is less than. So we go to B and we shade the points below that line. And now, step 25, shade the area above inequality C. We're going to shade above since it is greater than. So we go to C and we shade the points above that line. And we see the area of solutions where all 3 overlap is on the inner portion of these 3 points. So this would be the answer to question number 15. So that is how you go about solving question number 15. Let's now have a look at question number 16. Find the solutions by graphing the system of inequalities. Inequality A, x is greater than 1. Inequality B, y minus 3x is greater than or equal to negative 2. Inequality C, 3y minus x is less than 8. Pause the video, answer this question, and then press play when you are ready to begin. Step 1, isolate y on the left side of inequalities b and c. So starting with b, we have y minus 3x is greater than or equal to negative 2. So we'll start by adding 3x to both sides, showing us y is greater than or equal to 3x minus 2. So we can rewrite b with this expression here. And now for c, 3y minus x is less than 8. So we'll add x to both sides, showing us 3y is less than x plus 8. And now we want to remove this coefficient 3 by dividing both sides by 3, showing us y is less than x over 3 plus 8 over 3. Now we want to create value tables for a, b, and c. So step 2, change inequality a to an equation. So we change greater than to equal to. And since x is equal to 1, that means in our value table, all three x values will be 1. So our y values will be negative 1, 0, and 1. So this is our value table for a. And now for b, step 4, change inequality b to an equation. So we change greater than or equal to an equal sign. And now step 5, record 3 xy values for equation b in a value table. So we'll plug in negative 1, 0, and 1 for our x, and then record the corresponding y. When x is negative 1, y is 3 times negative 1, which is negative 3. Negative 3 minus 2 is negative 5. So when x is negative 1, y is negative 5. When x is 0, y is equal to 3 times 0, which is 0. 0 minus 2 is negative 2. So 0, negative 2 is the second point in this value table. And when x is positive 1, y is equal to 3 times 1, which is 3. 3 minus 2 is positive 1. So 1, 1 is the third value in this value table. So we'll put this value table to the side, and now we want to create one for c. So step 6, change inequality c to an equation. So we change less than to equal to. And now step 7, record 3 xy values for equation c in a value table. So we'll plug in negative 1, 0, and positive 1 for our x, and then record the y. When x is negative 1, we get negative 1/3 plus 8/3, which is equal to 7/3. So when x is negative 1, y is 7/3. When x is 0, we get 0/3 plus 8/3, which would be 8/3. So 0 and 8/3 is the second point in this value table. And when x is 1, we get 1/3 plus 8/3, which is 9/3. 9 divided by 3 is equal to 3. So when x is 1, y is 3. So now we have value tables for a, b, and c. So now we want to find the vertices where a and b cross each other, a and c cross each other, and b, c cross each other. So we'll begin by finding the vertex of a, b. Equation A tells us x is equal to 1. So step 8, we'll substitute x is equal to 1 into equation B here and solve for y, giving us y is equal to 3 times 1, which is 3. 3 minus 2 is equal to 1. So the vertex for AB is where x is 1 and y is 1. And now we can find the vertex for AC. So step 10, substitute x, which is 1, into equation C here, giving us y is equal to 1/3 plus 8/3, which is equal to 9/3 or 3. So the vertex for AC is where x is 1 and y is 3. And now the last vertex, BC. So we want to write both equations out. And since we cannot eliminate our x's here, we'll want to eliminate our y's. So y minus y will give us 0. So we want to subtract equation C from equation B. So we want to change these terms to common denominators. So 3x is equivalent to 9x over 3. And negative 2 is equivalent to negative 6 over 3. And now we can subtract equation C from equation B. So when we do so, we get y minus y, which is 0. 9x minus x is 8x over 3. Negative 6/3 minus 8/3 is negative 14/3. And now we've eliminated y, so we can solve for x. So we'll add 14/3 to both sides, giving us 14 over 3 is equal to 8x over 3. And now, to negate this coefficient of 8 over 3, we'll multiply both sides by the reciprocal, 3 over 8. So that cancels out this fraction, giving us x is equal to 14 over 8. 14 over 8 can be simplified to 7 over 4. So x is equal to 7/4, which is equivalent to 1.75. So now that we know x, we can substitute x into either equation B or C to solve for y. So when we plug it into equation B, we get y is equal to 3 times 1.75, which is equal to 5.25. 5.25 minus 2 is equal to 3.25. So we get the vertex for BC is 1.75 and 3.25. But if you plugged in x into equation C instead, you should get the same value for y. So y is equal to 1.75 over 3 plus 8 over 3. 1.75 plus 8 is equal to 9.75. 9 divided by 3 is 3. 75 divided by 3 is 25. So we get y is 3.25 again. So the vertex for BC is 1.75 and 3.25. And now with all three vertices and value tables for A, B, and C, we can now begin graphing. So step 16, plot our vertices here. So we sketch out a coordinate plane. We plot AB, which is 1, 1. We plot AC, which is 1, 3. And we plot BC, which is 1.75, 3.25. And now we go back to the value table for A, and step 17, plot the points from the value table of equation A. Our first point is 1, negative 1. Our second point is 1, 0. And our third point is 1, 1. And with these 3 points now, we'll be able to sketch A. So step 18, draw a dotted line through the points. Now go to the value table for B. Step 19, plot the points from the value table of equation B. Our first point is negative 1, negative 5. Our second point is 0, negative 2. And our third point is 1, 1. And with these 3 points, we can now sketch B. So step 20, draw a line through the points. A is a dotted line since it's greater than but not equal to. But B is a solid line since it's greater than or equal to. And now for C, step 21, plot the points from the value table of equation C. Our first point is negative 1, positive 7/3. Our second point is 0, positive 8/3. And our third point is 1, 3. So with these 3 points now, we can sketch C. So step 22, draw a dotted line through the points. and it's a dotted line since it's less than but not equal to. And now we can begin shading in the appropriate areas. So step 23, shade the area to the right of inequality A. It's to the right since we have x is greater than 1. The x values increase as we move to the right along this axis. So we go to A and shade the points to the right of A. Now step 24, shade the area above inequality B. We're going to shade above since it's greater than. So we go to B and we shade the points above that line. And now lastly, step 25, shade the area below inequality C. So we go to C and we shade the points below that line. And we see the area of solutions where all three overlap each other is on the inner part of these 3 points here. So this would be the answer to question number 16. So that is how you go about solving question number 16. Let's now have a look at question number 17. Find the solutions by graphing the system of inequalities. Inequality A, y minus 2x is less than 4. Inequality B, 2y plus 3x is less than 1. Inequality C, negative 3y minus 2x is less than 4. Pause the video, answer this question, and then press play when you are ready to begin. Step 1, isolate y on the left side of each inequality. So beginning with A, y minus 2x is less than 4. So we'll add 2x to both sides, giving us y is less than 2x plus 4. So A can be rewritten with this expression. And now B, 2y plus 3x is less than 1. So we begin by subtracting 3x from both sides, giving us 2y is less than negative 3x plus 1. To remove this coefficient of 2, we'll divide both sides by 2, giving us y is less than negative 3x over 2 plus 1 over 2. So we can rewrite b with this expression. And now C, we have negative 3y minus 2x is less than 4. So we'll add 2x to both sides, giving us negative 3y is less than 2x plus 4. And now we divide both sides by negative 3, giving us y is greater than. You'll have to reverse this sign since we're dividing both sides by a negative number, giving us 2x over negative 3, which is negative 2x over 3, plus 4 over negative 3, which would be negative 4/3. So C can be rewritten as y is greater than negative 2x over 3 minus 4 over 3. Now we want to create value tables for A, B, and C. So step 2, change inequality A to an equation. So we swap the less than sign with an equal sign. And now we plug in negative 1, 0, and 1 for our x and record the y. So when x is negative 1, y is equal to 2 times negative 1, which is negative 2. Negative 2 plus 4 is positive 2. So when x is negative 1, y is 2. We now plug in x is equal to 0, showing us y is equal to 2 times 0, which is 0. 0 plus 4 is equal to 4. So 0, 4 is the second point in this value table. And when x is equal to positive 1, y is equal to 2 times 1, which is 2. And 2 plus 4 is equal to 6. So when x is 1, y is 6. And now we can put this value table to the side and repeat the process for b. So step 4, change inequality b to an equation. So we swap the less than sign with the equal sign. And now we plug in -1, 0, and 1 for x and record the y's. So when x is -1, y is equal to -3 times -1, which is +3 over 2. 3 halves plus 1 half is equal to 4 halves. And 4 divided by 2 is 2. So when x is -1, y is 2. When x is 0, we get 0 plus 1 half, which is equal to 1 half, or 0.5. So 0 and 1 half, or 0.5, is the second point. And when x is +1, we get -3 times 1, which is -3 halves, plus 1 half, which would give you -2 over 2. -2 divided by 2 is -1. So when x is 1, y is -1. So now we put this value table to the side and repeat the process for C. So step 6, change inequality C to an equation. So we change greater than to equal. And now we plug in -1, 0, and 1 for x. So when x is -1, y is equal to -2 times -1, which is +2 thirds. 2 thirds minus 4 thirds is equal to -2 thirds. So -1, -2 thirds is the first point in this value table. When x is 0, we get 0 minus 4 thirds, which is equal to -4 thirds. So 0, -4 thirds is the second point in this value table. And when x is 1, we get -2 times 1, which is -2 thirds. -2 minus 4 would give us -6 over 3. And -6 divided by 3 is -2. So 1, -2 is the third point in this value table. And now that we have value tables for A, B, and C, we want to find the vertex for AB, find the vertex for AC, and then find the vertex for BC. So starting with AB, we want to write out the equations for both. And since we cannot eliminate our x's by adding or subtracting the equations, we'll focus on the y's. And if we subtract equation B from equation A, that will allow us to eliminate our y. So in order to do that, we need these terms to have a common denominator of 2. So 2x is equivalent to 4x over 2. And +4 is equivalent to 8 over 2. 4x over 2 is 2x. 8 over 2 is 4. So now that we have like terms, we can subtract equation B from equation A, giving us y minus y, which is 0. 4x minus -3x becomes 4x plus +3x, which is 7x over 2. And 8 minus 1 gives us 7 over 2. Now we want to subtract 7 halves from both sides, leaving us with -7 halves is equal to 7x over 2. And to remove the coefficient of 7 over 2, we want to multiply both sides by 2 over 7. The 2's cancel out, the 7's cancel out, leaving us with x is equal to -1. And now we can take this value for x and substitute it into either equation A or B. So if you substituted x into equation A, you should have gotten y is equal to 2 times -1, which is -2, plus 4, which is +2. So we get y is equal to 2. If you plug the -1 into B instead, you should get y is equal to 2. -3 times -1 becomes +3 over 2, plus 1 over 2, which gives us 4 over 2. And 4 over 2 is equivalent to 2. So the vertex for AB is where x is -1 and y is +2. And now we find vertex AC. So step 12, subtract equation C from equation A. Equation A, 2x is equivalent to 6x over 3, and 4 is equivalent to 12 over 3. Since we cannot eliminate our x's, we'll focus on the y's. Y minus y would allow us to eliminate y. So we subtract equation C from A, giving us y minus y, which is 0. 6x minus negative 2x is 6x plus positive 2x, which is 8x over 3. 12 thirds minus negative 4 thirds is 16 thirds. And now we can solve for x. So we'll subtract 16 thirds from both sides, giving us negative 16 thirds is equal to 8x over 3. And now to negate the coefficient negative 8 over 3, we'll multiply both sides by negative 3 over 8, leaving us with x is equal to 16 over negative 8. Negative 16 over 8 is equal to negative 2. So now we can substitute x is equal to negative 2 into either equation A or C, and then step 15, we can then solve for y. So if we plugged in negative 2 for x into equation A, we get y is equal to 2 times negative 2, which is negative 4. Negative 4 plus 4 is equal to 0. So we get y is equal to 0. Or if you plugged in x is negative 2 into equation C instead here, so we get negative 2 times negative 2, which gives us 4 over 3 minus 4 over 3. 4 over 3 minus 4 over 3 is equal to 0. So for vertex AC, we see it is where x is negative 2 and y is 0. And now that we have vertices AB and AC, we can find the vertex for BC. So we want to write out the equations for B and C and subtract equation C from equation B. But in order to do that, these four terms need to have the same denominator. So this one has a denominator of 2, and this equation has denominators of 3. So we can change them to denominators of 6 by multiplying these terms by 3 over 3 and these terms by 2 over 2. When we do so, we wind up with negative 9x over 6 plus 3 over 6. Multiply numerators and denominators by 3. And here, we multiply top and bottom by 2, giving us negative 4x over 6 minus 8 over 6. Now we can subtract equation C from equation B. When we do so, y minus y is equal to 0. Negative 9x minus negative 4x gives us negative 9x plus positive 4x, which is negative 5x over 6. And 3/6 minus negative 8/6 is 3/6 plus positive 8/6, which gives us positive 11/6. Now we want to subtract 11 over 6 from both sides, giving us negative 11 over 6 is equal to negative 5x over 6. And to remove the coefficient of negative 5 over 6, we'll multiply both sides by negative 6 over 5. That cancels the coefficient, showing us x is equal to. Our 6's cancel out. Negative times a negative makes a positive, leaving us with 11 over 5. And 11 divided by 5 is equivalent to 2.2. So we get x is equal to 2.2. So now step 18, we can substitute x into either equation B or C, and then step 19, solve for y. So if you plugged in 2.2 for x into equation B, you get y is equal to negative 1.5 times 2.2, which is negative 3.3. Negative 3.3 plus 0.5 is equal to negative 2.8. You also could have substituted x is equal to 2.2 into equation C to find the y value. If you did, you would have gotten negative 2 times 2.2, which is negative 4.4 over 3 minus 4 over 3. Negative 4.4 minus 4 would give you negative 8.4 over 3. And this is equivalent to negative 2.8. So now we have all three vertices, and we have value tables for A, B, and C. So we can begin graphing. So step 20, plot the vertices. We plot AB at negative 1, positive 2. We plot AC at negative 2, 0. And we plot BC at 2.2, negative 2.8. Now we go to our value table for A. In step 21, plot the points from the value table of equation A. Our first point is at negative 1, positive 2. Our second point is at 0, 4. And our third point is 1, 6. So now with these 3 points, we'll be able to sketch A. So step 22, draw a dotted line through the points. And it's dotted since it's less than. Now we move on to B. Step 23, plot the points from the value table of equation B. The first point is negative 1, 2. The second point is 0, 1 half. And the third point is 1, negative 1. And with these 3 points, we'll be able to sketch B. So step 24, draw a dotted line through the points. And again, the line is dotted since it's less than but not equal to. And now step 25, plot the points from the value table of equation C. So our first point is negative 1, negative 2/3. Our second point is 0, negative 4/3. And our third point is 1, negative 2. And with these 3 points, we'll now be able to sketch C. So step 26, draw a dotted line through the points. And it is dotted because it is greater but not equal to. So now we can begin shading in the appropriate areas. Step 27, shade the area below inequality A. And we're going to shade below since it's less than. So we go to A, shade the points below that line. Step 28, shade the area below inequality B. So we go to B, shade the points below that line. And now for C, step 29, shade the area above inequality C. It's going to be above since it's greater than. So we go to C and we shade the points above that line. And we see the overlap for all three occur on the inner portion of these 3 points. So this would be the solution to question number 17. So that is how you go about solving question number 17. Let's wrap up this video by completing question number 18. Find the solutions by graphing the system of inequalities. Inequality A, negative 2y plus 4x is less than 6. Inequality B, 6y minus 3x is less than 2. Inequality C, negative y minus 7x is less than 3. Pause the video, answer this question, and then press play when you are ready to begin. Step 1, isolate y on the left side of each inequality. So starting with A, negative 2y plus 4x is less than 6. We'll begin by subtracting 4x from both sides, giving us negative 2y is less than negative 4x plus 6. And now we'll divide both sides by negative 2, giving us y is greater than. Remember to reverse this since we're dividing both sides by a negative number. y is greater than, negative 4x divided by negative 2 becomes positive 2x, and positive 6 divided by negative 2 becomes negative 3. So A can be rewritten as y is greater than 2x minus 3. And now B, 6y minus 3x is less than 2. So we'll begin by adding 3x to both sides, giving us 6y is less than 3x plus 2. And now we divide both sides by 6, giving us y is less than 3x over 6 is equivalent to x over 2. 3 over 6 becomes 1/2. Plus 2 over 6, which can be simplified to 1/3. So B can be rewritten as y is less than x over 2 plus 1/3. And now C, negative y minus 7x is less than 3. We'll begin by adding 7x to both sides, leaving us with negative y is less than 7x plus 3. And now to get rid of this coefficient of negative 1, we'll divide both sides by negative 1, which means we have to reverse this from less than to greater than, leaving us with y is greater than negative 7x minus 3. So C can be rewritten with this expression here. And now we want to create value tables for A, B, and C. So step 2, change inequality A to an equation. So we change greater than to equal to. And now we want to plug in negative 1, 0, and 1 for x and record the y's. So step 3, record 3 xy values for equation A in a value table. When we do so, we get x is negative 1 and y is equal to 2 times negative 1, which is negative 2. Negative 2 minus 3 is negative 5. So negative 1, negative 5 is the first point in this value table. When x is 0, y is equal to 2 times 0, which is 0. And 0 minus 3 is negative 3. So 0, negative 3 is the second point in this value table. And when x is positive 1, 2 times 1 is positive 2. 2 minus 3 is negative 1. So 1, negative 1 is the third point in this value table. We can now put this value table to the side and create a value table for B. So step 4, change inequality B to an equation. So we change less than to equal. And now we plug in negative 1, 0, and 1 for x and record the y's. So step 5, record 3 xy values for equation B in a value table. So when x is negative 1, we get negative 1 over 2 plus 1 over 3. We want to change these to a common denominator so we can add them together. So negative 1/2 is equivalent to negative 3 over 6. 1/3 is equivalent to 2 over 6. Multiply this fraction by 3 over 3. Multiply this fraction by 2 over 2. Negative 3 plus 2 is negative 1 over 6. So when x is negative 1, y is negative 1/6. When x is 0, we get 0 plus 1/3, which is 1/3. So when x is 0, y is 1/3. And when x is 1, we get 1/2, or 3/6, plus 1/3, or 2/6. 3/6 plus 2/6 is equal to 5/6. So 1, 5/6 is the third point in this value table. We can now put this value table to the side and create one for C. So step 6, change inequality C to an equation. So we change greater than to equal to. And now step 7, record 3 xy values for equation C in a value table. So when x is negative 1, y is equal to negative 7 times negative 1, which is positive 7. 7 minus 3 is 4. So when x is negative 1, y is 4. When x is 0, y is equal to negative 7 times 0, which is 0, minus 3. So when x is 0, y is equal to negative 3. And when x is positive 1, y is equal to negative 7 times 1, which is negative 7. Negative 7 minus 3 is negative 10. So x is 1, y is negative 10 is the third point in this value table. And now that we have the value tables that will allow us to sketch A, B, and C, we want to focus on finding the vertices where A and B cross each other, where A and C cross each other, and where B and C cross each other. So let's start by focusing on the vertex of AB. So we want to write out equations A and B. We cannot eliminate our x's here by adding or subtracting the equations, so we'll focus on eliminating our y's. We can eliminate our y's by subtracting equation B from equation A. So we have denominators of 2 and 3 here. So we'll change all 4 of these terms to a denominator of 6. So we multiply these two terms by 6 over 6, giving us 12x over 6 minus 18 over 6. So for these two terms, we'll multiply this fraction by 3 over 3, giving us 3x over 6, plus 1/3, which we want to multiply by 2 over 2 to give us 2 over 6. So now we can subtract equation B from equation A. When we do so, we get y minus y, which is 0. 12x minus 3x is 9x over 6. Negative 18/6 minus 2/6 will give us negative 26. Now we want to add 20 over 6 to both sides, giving us 26 is equal to 9x over 6. And to cancel this coefficient of 9 over 6, we'll multiply both sides by the reciprocal 6 over 9, giving us x is equal to our 6 in the numerator here and denominator here cancel each other out, leaving us with 20 over 9. And this is also equivalent to 2.22. And now, step 10, substitute x into either equation A or B. And then step 11, solve for y. So if we plug in x is equal to 2.22 into A here, we get y is equal to 2 times 2.22, which is equal to 4.44 minus 3 will show us that y is equal to 1.44. So if you plug in x is equal to 2.22 into equation B, you'll get 2.22 over 2 plus 1/3. We want these to have the same denominator so that we can add them together. So we multiply this fraction by 3 over 3, giving us 6.66 over 6. And we multiply this fraction by 2 over 2, which would give us 2/6. Now with a common denominator, we can add the numerators, which would give us 6.66 plus 2, which is 8.66 over 6. And that is equivalent to 1.44. So the vertex for AB is where x is 2.22 and y is 1.44. Now, step 12, subtract equation C from equation A. And step 13, solve for x. So since we cannot add or subtract our x's to eliminate x, we'll focus on the y's. Y minus y will give us 0. So 2x minus negative 7x would give us positive 9x. And negative 3 minus negative 3 is negative 3 plus positive 3, which is 0. So we get 0 is equal to 9x. And now we divide both sides by 9, showing us x is equal to 0 divided by 9, which is 0. And now we can take x is equal to 0 and substitute it into either equation A or C, here or here. And then step 15, solve for y. So if you plugged in x is 0 into A, you would get y is equal to 2 times 0, which is 0. 0 minus 3 is equal to negative 3. So you should get y is equal to negative 3. or if you plugged in x is equal to 0 into C, you should get the same value for y. So we get y is equal to negative 7 times 0, which is 0. 0 minus 3 is equal to negative 3. So we see the vertex for AC is where x is 0 and y is negative 3. And for our third vertex, BC, we want to write out the two equations and then subtract equation C from equation B. In order to do so, we need these four terms to have the same denominator. So we'll multiply this fraction by 3 over 3, so we get a denominator of 6. That would give us 3x over 6. And we'll multiply this fraction by 2 over 2 to give us 2 over 6. And here we'll multiply negative 7x by 6 over 6, which gives us negative 42x over 6. And negative 3 times 6 over 6 would give us negative 18 over 6. So now we can subtract equation C from equation B. When we do so, we get y minus y, which is 0. 3x minus negative 42x is equal to 3x plus positive 42x, which gives us 45x over 6. And 2/6 minus negative 18/6 is equal to 2/6 plus positive 18/6, which is 20 over 6. And now that we've eliminated our y, we can solve for x. So we'll subtract 20 over 6 from both sides, giving us negative 20 over 6 is equal to 45x over 6. And to solve for x, we multiply both sides by 6 over 45 to eliminate this coefficient, leaving us with negative 20 over 45, since our 6's cancel out. And if you divide 20 by 5, you get 4. If you divide 45 by 5, you get 9. So x is equal to negative 4/9, and this is equivalent to negative 0.44. So now that we know x, we can substitute x into either equation B or C and then solve for y. We'll plug in the fraction into B since it'll make it a little bit easier to find y. So whenever you are dividing a fraction by a fraction, it is equivalent to multiplying the fraction in the numerator by the reciprocal of the denominator. The denominator is 2, which is equivalent to 2 over 1. So if we multiply the numerator by the reciprocal, that would be 1 over 2 plus 1/3. So y is equal to negative 4 over 18 plus 1/3. To get the same denominator, we multiply 1/3 by 6 over 6. Now we can combine the like terms. Negative 4 plus 6 is positive 2 over 18, which is equivalent to 1/9. So y is equal to 1/9, or 0.11. If you chose to substitute x into C instead, you would have gotten y is equal to negative 7 times negative 4/9 minus 3. Negative 7 times negative 4 is positive 28 over 9. So we multiply negative 3 by 9 over 9, which would give us negative 27 over 9. And now 28 minus 27 would give us 1 over 9, which is equal to 0.11. So the vertex for BC is where x is negative 0.44 and y is positive 0.11. Now we have value tables for A, B, and C, and we have all three vertices, so we can begin graphing. Step 20, plot the vertices. So vertex AB is where x is 2.22 and y is 1.44. Vertex AC is where x is 0 and y is negative 3. And vertex BC is where x is negative 0.44 and y is positive 0.11. Now go back to the value table for A. In step 21, plot the points from the value table of equation A. So our first point is -1, -5. Our second point is 0, -3. And our third point is 1, -1. So now with these 3 points, we can draw the line for A. So step 22, draw a dotted line through the points. And it's dotted since we have greater than but not equal to. Now we move on to B. Step 23, plot the points from the value table of equation B. So go back to the value table in your notes. And now plot the points. Our first point is -1, -1/6. Our second point is 0, 1/3. And our third point is 1, 5/6. And with these 3 points, we can now sketch B. So step 24, draw a dotted line through the points. And it's dotted since it's less than but not equal to. Step 25, plot the points from the value table of equation C. So our first point is -1, +4. Our second point is 0, -3. And our third point is 1, -10. So with these 3 points, we can now sketch C. So step 26, draw a dotted line through the points. And it's dotted since it's greater than but not equal to. Now we can begin shading the appropriate areas. So step 27, shade the area above inequality A. So you go to A and you shade the points above that line. Step 28, shade the area below inequality B. So we go to B, we shade the points below that line. And it's below since it's less than. And for step 29, shade the area above inequality C. We're going to shade above since it's greater than. So you go to C and you shade the area above that line. And we see the area of solutions is on the inner portion of these 3 points. That's where all 3 of these solutions overlap. So this would be the solution to question number 18. And that wraps up this video, practice set number 1 to our 2x2 systems chapter. Should you have any follow-up questions, feel free to leave them in the comments section. Or you can contact a tutor in your neighborhood by visiting bookandtable.com or by downloading our app on the App Store. Peace.